formula. I want to use the formula because I have resorted to a quadratic equation. Initially, I have a simultaneous equation of which one is linear, the second one is quadratic. Now, I've been able to use substitution method to resolve it to what is known as a quadratic equation. Then here I have my A to be equals to 4, my B to be equals to minus 37, and my C to be equals to 78. So, we recall that X will be minus B plus or minus square root of B squared minus 4AC over 2A. That is the formula. So here I have X to be equals to, what is my B? My B is minus 37. So I'll have minus 37 plus or minus square root of minus 37 square minus 4 into A, which is 4, and into C, which is 78 over 2 times A. What's my A? 4. So by the use of electronic device, which is a calculator, I can use that to resolve this, and by so doing I'll have 37 minus 37 times minus 37, that's 37 squared. That gives me, so automatically I will have X to be equal to minus times minus plus 37 plus or minus square root of minus 37 squared will give me 1369. Then this one, 16 times 78, 16 times 78 will give me minus 1248, 1248 over 8. Then I will now have X to be equals to 37 plus or minus 1369. That gives me square root of 121 over 8. And the square root of 121 is 11. So square root of 121 is 11. So I can have my X to be equals to 37 plus or minus 11 over 8. And if I want to resolve this, I will have X to be equals to 37 plus 11 over 8, or 37 minus 11 over 8. So 37 plus 11, so that will be 49 over 8. No, 48 over 8. That will be 48 over 8. Or this one will be 26 over 8. That will be 26 over 8. So 4 year 2, 4 year 12, 2 year 1, 2 year 6. So X equals to 6, 2 year 4, 2 year 13. So or 13 over 4. So these are the two values of my X. And since I've gotten X to be 6 or 13 over 4, remember that I will have two values for X, two values for Y. Now, when X equals to 6 using equation 1, when X equals to 6. So the equation 1 is 2X minus Y equals to 6. When X is 6, so I have 2 into 6 equals to minus Y equals to 6. So this one will be 12 minus Y equals to 6. And minus Y will be 6 minus 12. And minus Y will definitely be minus 6. So my Y will be 6. Therefore, when X is 6, Y is also 6. Then, when X is 13, when X is 13 over 4, using that same equation 1, so I'll have 2 into 13 over 4 minus Y equals to 10. then these 2, here 1, 2 here 2. So then I will have 13 over 2 minus y equals to 10, which implies that. So I can bring this, I take this my y to the other side, it becomes plus y, then I bring this one here. So I have y equals to 13 over 2 minus 10. Then y equals to 13 over 2 minus 10. So you find the LCM. LCM is 2. 2 here 2. 2 times 2 here 1. 1 times this 13 minus 2. 1 into 2, 2 times is 20. So this one will now give me minus 7 over 2. That's minus 7 over 2. Therefore, when x is equal to 6, y equals to 6, then when x is equal to 13, when x equals to 13 over 4, 13 over 4, my y is equal to minus 7 over 2. And these are the solutions to the example 1 question. Example where we are to talk about word problem. Word problem on linear equation, simultaneous linear equation, quadratic equation, one linear and one quadratic. Let's use this example 1 to justify our claim. In example 1, we have one number exceed another by 5. The sum of their squares is 157. What are the numbers? So, to solve this example 1, the first thing we need to do is to assume that let the first number be x. Let the second number be y. Since it is stated that one number exceeds another by 5, automatically that means the difference between the two numbers must definitely give us 5. So that means x minus y is equal to 5. This is a mathematical equation for that statement. Now, the sum of their squares is 157. That means the square of the first one is x. So x squared, sum plus y squared must give us 157. Let's call this equation 1 and let's call this equation 2. If you look at equation 1 is a linear equation because the degree of the variable is 1. The highest degree of the variable is 1. While the equation 2 is a quadratic equation simply because the highest degree of our variable is 2. So here, equation 1 is simpler compared to equation 2. So what we do next is to make x. You can also make y, but I prefer to make x the subject of the formula. So if I want to make x the subject of the formula from equation 1, then I will have x equals to 5 plus y. Then I will substitute, I call this equation 3. Then I substitute this into equation 2. I substitute this into equation 2. If I substitute this into equation 2, I will have x squared, then it becomes 5 plus y, all squared, plus y squared is equal to 157. If I expand this by that short method, putting this on this, that becomes 5 squared, that is 25. Use this to multiply this, 10. 10 times this plus 10y. Then use this, put it on this, then become y squared. Plus y squared that is already here, then 157. To simplify this, I will have 25 plus 10y plus 2y squared equals to 157. Then I want to rearrange to make it look like a quadratic equation proper. Then it will become 2y squared plus 10y plus 25 minus 157 is equal to 0. Then to simplify this, I'll have 2y squared plus 10y. Then this one will be minus 132. That will be minus 132. That's 132 equal to 0. Then I resolve to, I want to use the formula here. A equals to 2, B equals to 10, then your C is equals to minus 132. By recalling the formula, we have X, but this time I will call it Y, to be equal to minus B plus or minus square root of B squared minus 4AC over 2A. Then here I have my Y to be equal to, what is my B? Minus 10 plus or minus square root of 10 squared minus 4 into 10 over into 2 rather, because our A is 2, into 2, then into minus 132, then over 2 times A. What's our A? 2. So to resolve this, I have Y to be equal to minus 10 plus or minus square of 100, square of 10 is 100. Then this is minus 8. 132 times 8, that will give us 6. 1, 5, 1, that's 2. And this as 1056. And let's confirm that 132 times 8, that gives 1056. Remember, there is a minus here. Minus times minus plus, so automatically I have Y equals to, so I can put this as plus 1056. So 2 times 2 gives 4. So now I have minus 10 plus or minus this plus this.